Hey everybody, this is Larry. This is day 24 of the March. Ooh, missed quick. Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm, boats to save people. I hope this farm is boatloads of fun, so yeah, join me on Discord to let me know what you think about that comment. A little bit tired today, I don't know why, but hope y'all doing all right. It's middle of the week. Hope y'all just like having a good week and all that good stuff. Okay, so let's see. So you're given people's I, the weight of I person, and an infinite amount of boats where each boat can carry a weight maximum weight of limit. Each boat carries at most 2 people at the same time, providing the sum of the weight of the people is at most limit. Return the minimum number of boats to carry every given person. Okay. Let's see. I think greedy is probably the way to go. Right? Oh, excuse me. Oh man, wow. Okay, so I think it's so the answer is gonna be the way. Let's see. So the answer is going to be some sort of greedy, right? Just because we're trying to maximize the number of boats, and my idea would be that the key thing to notice is that you can there are only two choices you can make with a boat, which is to carry one person or 2 people, right? And then you have a couple of things that you might do, which is that it's hard to kind of explain it. What I'm thinking is more like some sort of property where when you take out 1 or 2 people, the rest of the answer is still true, right? So almost kind of like greedy in that way, in that the invariant, and we talk about invariant a lot on this channel, and also because it's important for these kind of problem solving, is that the invariant after taking out people will be the same, right? And I think the way that I would think about it is that it is basically going from the way that I would think about it is going from large to small, and then see if you can fit another person on that boat. Because really there are only a couple. There are a couple of ways you can think about this, right? One is that there is a wrong way to be greedy, right? For example, if your limit is so let's say you have 2, 2, 1, 1, right? And your limit is equal to 3. If you do 1, 1 on one boat, then obviously you're gonna end up with 3 boats, right? And that is clearly suboptimal because you can do 1, 2 and 1, 2 to make it 2 boats, right? So, however, if you get it from greedy in a way, going from the large person, well, like the largest person, well, because that person always going to take a boat anyway, assuming that it is under limit. Yep. It was always going to take a boat. The question is, okay, let's say you have the largest person that will always have his own boat, their own boat. In that case, can it fit another person, right? And it also in that case, you would choose greedily. What is the biggest person that you can remove to pair in the same boat together? And in that case, then you would take that person because one is forced, and then the other person on that boat would be almost like a freebie, right? If you could fit in someone, you should fit in someone, and so forth. I think that's the idea, and I think that should be good. The question is then now, how do you implement this, right? What is the solution? There are a couple of ways you can do. I think you could have I think the way that I would do it is just by 2 pointers. But you can also, if you're a little bit sketch with the 2 pointers, or maybe 2 pointers is not the right way to say it, because I mean 2 pointers is precise. Even though you are going to use 2 pointers, but the idea is that, or you can also use binary search or something like that. But the idea behind the 2 point algorithm is just having a pointer on our current index, and then having a second pointer that is in the middle of the. I mean, it will start in the beginning, but the second pointer will, with the middle, match these two, and then move to the right, and then move to the right, as you use them, and that should be good. The idea, of course, is also based on the second observational invariant that for every number that you're looking at, you're trying to get the biggest number that you haven't used before that is under the limit 3. And of course, as you go from left to right to make these numbers smaller, actually, maybe I'm more. Wait, give me a second. Maybe I was wrong on this one. As you make these numbers smaller, can you do it with 2 pointers? Maybe I was wrong. I was going to say that as you make these numbers smaller, you also make this number smaller, but that's not true actually. So I messed up here in my explanation. Well, in that case, then we can just do binary search every time. I mean that I know is right. And you can also use like a hash table or something like that, given that 3 is 10 to the 4th. But yeah. Okay, yeah, let's do that. Let me think about this for a second. I do wonder if there's a linear time solution, which is what I'm thinking about. Because as you use these numbers, I also wonder if there is a property where So one way to do about it, so one way to solve this problem, and that is going to be right, is that you sort this, and then in a sorted list or something like that, and then you binary search every time, and then remove them from the list as you do a binary search. That'll work. That'll be n log n, and that's fun. But I'm trying to think whether you can do it in linear time, and I also have a vague idea of a linear time algorithm, but I cannot. I do not know off my head whether that is correct. And the idea of that algorithm is that, let's say obviously you still sort it. So M433, maybe even sort it the other way. I guess it doesn't really matter. I think it's sufficient. I have a really funky solution, and I don't know that I can prove it. But the idea is that you just match this 3 with this 4. You will match this 3 with this 5, and you do it for every number to see if it's right. To see if you need 1 bolt or 2 bolt for these pair of people. I have some recollection that this may work, but maybe I'm wrong. All right. Well, I think the first thing I would. Wow, this one is like. I know that I just woke up from a nap, and that's why you could see that I'm a little sluggish. But this one is still throwing me for a loop, because these mathematical things are kind of very tricky. Because I have a lot of feelings, a lot of quote unquote intuition from experience, but for me to actually think about the proofs is a bit trickier. With that said, if this was a contest, let's step back for a second. If this was a contest, saying the n is equal to 10 to the, sorry, 5 times 10 to the fourth, that would be good enough for me to use an n log n solution, because the n log n solution, I know that I don't have to prove, right? Yeah. So let's actually do that, and then maybe afterwards, maybe not. We'll see if I can prove this to be better, right? So okay, so let's use sorted list. That's what's important. I think sorted list you can have a key. Maybe I'm wrong on this one. Hang on, let me Google this real quick. Yeah, okay. So then now, basically what I want to do is sort it backwards. And then also let's just do people. All right. Let's run it real quick so I could see if this key thing is right. Okay, well, something like that. I don't remember the. Huh. Forget how to just get a list of the items and sort a list. Give me a second. So there was like a dot items or dot something. Maybe not. I thought I could. I feel like this should work, but maybe the key thing is making it up. Oh no. Okay, it did work. It printed out that out. I just kind of missed it. Okay, because I don't know. It's a bunch of stuff. Okay, so yeah, so it works like that. So then now all we have to do is while length of SL is greater than 0, let's just say item is equal as of 0. Also, let's keep track of the count of the number of boats. So boats is equal to 0. We get this item, we remove this item, and then we do a binary bisect left on limit minus item. Is that right? So basically we run so this will give us, so I'm because we sorted the other way, I'm not used to sorting it the other way, so the bisect left I just have to make sure that when it goes over it's smaller, right? So yeah, so index is equal to this. If index is less than SL, the length of the list, that means that is a good item. Then yeah, again we move that, and then that is 1 vote, and that's pretty much it. I know that I spent a long time talking about it, but I think this should be right, just because it just has to be. It's just doing it one item at a time, and yeah. Let's give it submit. But I do want that'll be funny if I get time to exceed it. No, but it is very slow. I do wonder if there's a linear time and I'm just not thinking it correctly. So let's take a look at past Larry. Oh, just in case you want to know, this is n log n, because for each item, we're gonna remove the first item, and this is binary search on every operation. Yeah, and this sorting, so it's gonna be n log n. Yeah, and O of n space for the sorted list. Did I do a linear time one? Huh. So I guess, well, I guess you still need to sort, so I forgot about the sorting. So I guess, yeah, huh. I mean, I guess that's the way it is. You just pair what I was talking about earlier. Pair the heaviest with the lightest, and then just walk with the 2 pointers. Yeah, I guess that will work. I don't know. Maybe I'm just really off today. Apologies, my friends. But sometimes I want to say it. As long as you solve it, it's fine. Though this is the timing is so much slow. Usually it's only a little bit slower, and I don't care about it. Even if it's like double the speed, or double the slowness, I don't mind. But this is a little bit slow, so it's a little bit concerning. But that said, it has the same complexity and login. And if you need to sort it, you're not going to do better than that. You can maybe do some sort of quote unquote linear time algorithm with respect to putting everything in a hash table, like I mentioned, and then kind of walk it up. It's kind of like a counting sort, so it's not really linear. It's like O of alpha or something like that, as you kind of walk up, where alpha is the limit. But in this case, that's also smaller than whatever, so that's good too. Yeah, that's all I have for today. I'm a little bit off, so my apologies. Hope this was educational, though. Hope you learned something. That's all I have, though. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.